Hey, fellow YoraHomers, I've got a couple of neat things to show you tonight. These are the laser shields as well as the Z-axis that I've been working for. So each of these represents a laser shield for either a different machine. In the case, this is the 3018 laser shield. And these both are for the 6550. This here's intended for a stock machine. And then this is a combination laser shield adjustable Z-axis. They're actually two different parts, but the laser shield for the Z-axis upgrade is different. The design is different because I use the same holes to mount the Z-axis as I do for this here. So I'm going to demonstrate how these all work. So this is going to be this minute's going to be a few minutes long to show all that. So let me set my camera down, and I will start with the 3018. So these are the elements you will get with the kit, and the installation. I mean, I don't know if I need to do a formal video or if this will count, but basically you pass the two laser wires, which you'll have to unplug. And then with the magnets facing forward, you slide this sleeve over the top of the laser, and it kind of clips. So that is basically how that mounts. And then these would go back to the controller. Soon we will be offering a laser power board mount similar to the 6550 that goes here. It will clip on here, and then your laser power board will go up here. I don't have one printed right now. I had a prototype kicking around, but I don't know where it is. So I'll do another video for that one, but that's real easy. Anyway, once this bracket is seated, and it will push down, there it goes, and it will push down all the way. This is the shield itself. You'll notice there's magnets here, and there's a gap here. And essentially what you do is you line up that gap with the lens, you push it to the back of the laser, and then you bring it up. That's it. So this material that we're using is specifically for the wavelength of laser modules that we sell. Even though it's orange, it is the correct material. It's not just tinted acrylic, it's a specific laser filter material. We'll have more information on that, but we're sourcing it from a laser company that sells it specifically for this purpose, for shielding from laser. To remove, you simply pull it down and out. Now this, you'll notice the Z-axis on the 3018 is actually pretty far down. It's about 2/3 down. So if you want more clearance, if your workpiece is taller, you'll want to raise the Z-axis on this. That's all. But yeah, I have this gapped such that I believe it's about 10 millimeters from ideal. So you'll still need to focus your laser and whatnot, which is why I made this easy to remove as well, so you can get right at the laser, focus it to your material at the 1 3/4 inches, and then go ahead and install that. So that's the 3018. Now, well, I'm doing it silly here. All right, I don't have a 6550 on the bench right now, so I just figured I would demonstrate how this works with the actual business end. So this is your, this is the plate. This is a stock plate, and this is the stock mounting position of the laser. So normally this connects to a plate on the other side with the spacers and wheels and whatnot, and this is what rides on the gantry. So this is the stock plate from a 6550. And installation will basically be, you will have to take, unfortunately, this off, but only if you're going to a Z. So if you just buy the laser shield, this will be on your machine. So let me demonstrate that first. This is what will come with the kit. You will get the shield, and you will get 4 of these screws. I'm not going to promise they're black. We haven't sourced them yet, but these are out of my own personal supply, but you'll get these 4 screws. Now, let's see if I can get this. It's a little tricky because I got to film it. I have a little mini tripod here, so let's see if I can do this. That makes sense. All right, so we'll turn it so it kind of makes sense. Now, here's the installation. Bearing in mind, this is on your machine. It can stay on your machine. So if you're not doing a Z-axis, if all you want is this laser shield here, for an otherwise stock machine, you're going to take, and I believe we're going to try to include an Allen key, because this is actually not metric, it's standard, so none of the machines would have come with it. I intentionally had to do that because the holes on this are metric. When you look at the holes, the ones that are in use are this, and then the same on the other side. These smaller holes here aren't actually used on our machine, so we're going to take advantage of those. So the way this installation works is you're going to take these 4 screws and you're going to put them in these little free holes. So, and I haven't done it on this plate, so this is a good exemplar. Not hard at all. So that's 1. Two. So because I'm using a standard size, it will actually bite into this hole a little bit because it's a metric hole, and the standard size is just a little bigger. So we don't need nuts. We don't need any other hardware. It's gonna just kind of make its own little threads. It's nice and tight. And again, this can be on the gantry while you do this. You don't have to take it off. So very simple installation because I'm demonstrating it to you, and it's about a 2-minute job. So this is the 4th and last screw. Okay, so we have basically our 4 screws in place. Now these wires normally are going up to your laser power module. Now I'll kind of pretend this is on the laser mounted to the gantry. The way this goes on, you slide it. Again, you'll see this kind of a smaller groove, but you're going to slide that over the lens and then up, and it magnets right to those 4 screws. Again, I gap this so it's about, I think it's about 1 centimeter. We'll have those measurements. So to take it off, you just slide it down, and you don't need that much clearance. So to take it off, you just slide it down a little and off it goes. I have tested this on a machine when I was designing it. There's plenty of clearance. But having an adjustable Z-axis is better. So if really you just want laser shielding and you want to keep your machine stock, this is your answer. You just saw how easy that is to install. You see how simple it is to put on and off. So you can focus your laser, slap that on, you're good to go. Same laser shielding materials used in all these. Now, so that is for a stock machine. Now for the ultimate upgrade, I'm going to remove these screws because they are not what we need for the next one. Bear with me. Ooh, I actually like this smaller tripod. I might use this for some assembly videos going forward. I think I can do a little more with it. All right. So the coupe de gras, and this is actually in 2 parts, so I'm going to separate it. Okay. So this is the laser. Ooh, can't see that good. Let me move stuff. All right, we're going to need these two. And this. Okay. So this is our laser shield for our Z-axis upgrade. I'm very proud of this. This has taken an insane amount of design work. This is the Mark III. No joke. This is the 3rd revision to the Z-axis. My original design was personal. I used it only on my new machine. I revised the design a little bit in a Mark II, and then I had to create a Mark III to incorporate the laser shield because it just makes sense to have it sort of all be an integrated solution. So I'll show you how this one works. Now, to install this, you will need to take your gantry, your laser off. And in order to do that, you will have to take, you know, the trolley that this runs on off the gantry. Because you can't get at the screws on the back of this without taking this apart. So you unfortunately will have to take that apart on your gantry to do this install because you're removing the laser. And the only way to get at the screws, I didn't design the 6550. If I did, I would have found a way to remove the screws without frickin' taking the whole thing apart. So you're going to basically remove the laser from the plate. So this is our plate in the proper orientation. You're going to take the Z-axis assembly. This is what you'll get. This is how you will get it pre-assembled. You will notice that the holes, these 4 holes, line up with those same 4 holes I used for the screws for that magnetic mount. Now this is going to come with longer standard screws. So we're going to basically do the same thing we did for the magnetic mount on the other one, only it's going to use these longer screws and they're going to go through these holes. And I know you can't see much, but quite frankly you really don't need to. I'll show you when I'm done what I've done here, but this is not, I mean this, I'm not going to lie, I don't think this could get easier. There's not even nuts on the back. These are just threading right into those holes on the acrylic. Same place I installed the 4 shorter screws for the magnetic mount. Alright. By the way, this is going to be the most useful upgrade you do to your machine. The drag chains are useful, but they're more convenient. Getting the wires out of the way. This makes life a million times easier when using your laser. This is actually one of the first things. The first thing I designed for the laser was the cover for the board because it bothered me that it was open. Second thing I designed was the power board mount because I wasn't going to use zip ties on the top of my machine. I didn't think that would look very nice. Third thing I designed was the Z-axis. And actually the drag chains were kind of a parallel effort. Alright, so this is what you'll end up with. Alright. This is very secure, even though there's no nuts on the back. These are basically flush. They stick out a teeny bit, but it's fine. But this is now, so this is where the laser was, and we're mounting it from the front. Once you've done this, you can actually reassemble your gantry if you like. So this is how, the original design on this, I had holes on the sides and you would actually line it up. But we found that these holes aren't always consistent between the lasers. People are finding stuff in them, all that. So I went to a clip design. So this is pretty sweet. You basically slide the laser into these clips. And then the key is that you get it all the way down. And then on the side here, there's a little notch. You're going to want to push your laser down so that it notches into that notch. will kind of snap in. So you'll see it's nice and flush. No screws. These clamps just hold it. Sometimes the clamps aren't always like right all the way flush, but I made the tabs on top long enough. They'll hold the laser. There's no force really going on here. Okay, so I'm going to demonstrate a couple. You're getting a little bonus because the Z-axis is included in this video. So this is now on your laser. This knob will lower and raise the laser unit. So you turn it, and it's easier to demonstrate sideways. You can see that the laser is slowly moving down here if you watch. So I guess it would be better to do it that way. It's tough working around the camera. Let me move my hand here. There we go. So what you'll do is, I'm going to show you how this works. Again, sorry it's not on the machine, but I think you'll get the idea. Let's say this piece of paper is your workpiece. Well, something I haven't pointed out yet is this is my own design. I call it a Z probe. Okay. So the Z probe slides down like so. There's a little notch right there that stops it. This from here to here minus the focus. So, I mean, this moves in and out a hair when you focus it. It's not much. And I basically designed this to be exactly 46.5 millimeters from the end of the lens when it's in focus. So why this is important is, and this is how I've been using my machine since I bought it, because I designed this early on. I never used it without it. What you do is you put your workpiece on the table. You lower the Z probe, it just slides down and it stops. And then you basically turn this until the Z probe touches your workpiece. If it touches your workpiece, then you know you have perfect focus. So the first time, what you'll do is, so let's say this was the first time since I just installed this. This was on the machine. I would lower it until the Z probe touched, and then I would focus my laser so that it was perfect. You'll never have to focus your laser again. As long as the spring's working properly and your laser doesn't lose focus. In any future time, what you're going to do is, at that point, you can then retract this Z probe and burn. Now, if let's say you have something taller, let's say okay, we're done with that. Well, now we want to burn on this. Well, it's much closer. So you lower your Z probe, and then it's going to not go down all the way. And you lift your laser up until you can fully extend your Z probe. But basically, as long as you focused it so that when this is touching the workpiece, it's in focus. All you have to do is move your laser up and down. You can lay your piece right on your work area. Doesn't matter what height it is. And you're now just moving the laser. You never have to refocus. So I'm telling you, when you use this, and I'll do a demonstration when I've demonstrated my personal one. This function here is different. The design is updated, but the function is the same. Now, that's the Z probe, and I'm telling you, you're going to want this, because then you don't need the little table you raise up and down. You're not finding crap to prop your work pieces on to get it at the optimal distance. All you're doing is turning this knob. The other cool thing is, if you're cutting through something really thick, you can actually lower the laser a hair each time. So I've done that. When I'm cutting something deep and it's getting beyond the optimal focus distance, I can crank the laser down a little bit, and it'll basically get more of the it'll be able to go deeper, because I'm essentially refocusing the laser. I'm just dropping the laser down so it's in better focus. Okay, the threads on this are very fine, so you have, I don't even think it goes a millimeter with one turn. It's not even, I think it's less than half a millimeter. So All right, final demonstration. This is a 20-minute video. I wasn't expecting that. Final demonstration is so now we have the laser shroud for this unit. So I did have to basically redesign it. Same filter material, but if you'll notice, there's a notch in the bottom here. It's easier to see from the side. There's a small notch. This is actually the trickiest one to put on. It's not hard, but you have to know how to line it up. So this little flat piece is going to basically go in that notch. So when it's installed, you're going to put the shield in and up. And I mean, you notice I didn't have to do anything. Usually it finds the notch, but you'll know if you pull on it, it's solid. The magnets are in the sides, here and here. To remove it, you pull it down and off. So again, you can kind of go in and just slightly up. And you'll know, like that time it didn't find the notch right away. I had to kind of wiggle it. But yeah, I mean, I've been using it. You get the hang of it. It goes. It pretty much wants to go, and it'll be. Everything won't line up unless it's in that notch. But that's really, I mean, this is all flat except for that notch. So it's really, if you look from this angle, that's really the only place that it can go. These magnets are really strong, and they'll want to pull it there. So if you don't have it right, it'll just kind of pop in. So, and you can't use the Z probe with the shroud on, but you wouldn't anyway. It's easy enough to remove, set your depth, put back, and off you go. So, coming very soon, you will have, for those that don't want a Z probe, you'll have the stock laser shroud. For those that do, I believe it's going to be a package. I don't think we've decided how we're going to sell this, but I honestly think it just makes sense to sell this as one complete unit since the magnets are integrated. I think that's how we're going to do it, but don't quote me. And then last but not least, what I started with, the 3018. Not leaving you out. So, coming soon. And then again, there will be a laser power board mount available for this 3018 as well. And I'm going to be doing a drag chain for this too, for sure. That'll be actually pretty simple. It's just been working on these laser shields because I like the safety aspect. So, if you have any questions, feel free to reach out. But I think this is going to be these are going to be some I think this right here will be the most exciting upgrade. And I mean, if people sort of use it once or twice who are familiar with the 6550 with the Z Pro, forget the laser shield for a minute. There's just the adjustable Z axis. Once you get used to this Z probe, and you never focus your laser again, and you don't have to prop your material up, you'll fall in love with this capability. It's just absolutely, it's mind-blowing the difference it makes in using the laser. So I really think that this is going to be popular once folks kind of get it. So I don't know, maybe I'll do some more demonstration videos of it once I have it on a machine. My machine does have the Mark 1 on it, the original design, which replaces this whole plate and the back plate. Way, way, way more tedious. It's kind of funny. I thought that was the way we were going to have to go, which is one of the reasons I've put off this, because I knew that was going to be a lot of work and a lot of production to make all those plates. And then actually, it's as I was designing the laser shields, I kind of looked at it, and it's, like anything, you have sort of fresh eyes, and I said, wait a minute, I think I can get this to fit on the stock plate and use those 4 holes as mounting points. And that was my eureka moment. So that made this Z-axis upgrade way simpler to install, also way easier to produce. So this is a late prototype. I actually am still working on this design. I'm trying to get the gap, the tolerances in here between these 2 pieces that meet a little looser. This one's kind of tight. I just printed one actually today, and it was very close, where this is not. See, if it's too loose, you get play in the laser, and you don't want that, because that will make it not, it won't be accurate, because as it moves, it might rattle. So, but if it's too tight, then you have to sand the production aspects. You have to sand these parts to get them to move freely. So it's very tricky when you're talking about a sliding part, or 2 sliding parts that mate the way these guys do. You can see it's actually a pretty complicated rail system in there. So to get those tolerances such that they're not so loose that it rattles, but not too tight that it's hard to turn. So this one's a little harder to turn than I would like. The production versions will be will definitely be easier. Like mine, you just turn with your finger. That's how it should be. And that's how, when you buy them, that's how they'll be. They'll be all pre-assembled and pre-tested. So anyway, I'm going to wrap this up, but hope folks are excited about this. Let me know if you have any questions.